So, welcome everybody. Hope you enjoyed your coffee time. And welcome to our talk about the new plugin DSL. So, I am Stefan Oehme, Gradle core engineer, and here's my partner in crime.
I'm Pepper Liebeck-Job.
Also one of our trusted Gradle core engineers. And yeah, we wanted to take this opportunity to not just walk you through the features that we built very recently for the plugin DSL, but instead, we wanted to take a step back and give you the bigger picture about how does the whole plugin system fit into the whole Gradle story. Where did we come from? What are the problems with the existing system? So why are we even bothering doing a new one, right? Where do we want to be in the future? And where are we and how can you help us? So to get this started, I thought it would be great to just all agree on a definition of what the hell a plugin even is. Because you all know that plugins are at the very heart of Gradle. I mean, anything interesting that happens in your build probably happens thanks to a plugin. So it might be a good idea to get some terminology down. So what is a plugin? A plugin, first and foremost, is a piece of logic. Obviously, you want to do something. But with whom? Well, a plugin has some target. That target, most of the time, will be a project. Has anybody ever written a plugin for something else than a project? Just raise your hands. Great. Some real expert here. So you can also write plugins for the settings script or plugins for init scripts even. Yeah? So we have this generic term, the target, that we will refer to here quite a lot. Now, just one plugin might be a little boring. Your build probably needs a little more. So plugins quite often have some dependencies. That might be other plugins. For instance, the checkstyle plugin works with the Java plugin. It might also be just some arbitrary library. There are lots and lots of plugins out there that use Google Java or Apache Commons Lang, etc. So plugins need dependencies. And then finally, most interesting plugins also define some kind of API that you work with. So for instance, the Java plugin defines the Java compile task so that you can either reuse it to define your own compilation steps, or so that you can just refer to it and say, hey, all Java compile tasks shall please have the UTF-8 encoding. Yeah? So this is what makes up a plugin. Some logic with some dependencies, maybe an API that is applied to a target. Now, you might be surprised by all the things that are plugins, or that should be thought of as plugins. The most obvious ones that you all know are binary plugins. So plugins that are written in Java or Kotlin or Groovy, whatever language you fancy, really, as long as it runs on the JVM. And that's a class that just implements the plugin interface, which has one method called apply and takes the target, and then does something with the target. And you can write those plugins given any kind of target, project, settings, Gradle, etc. 99% of the time, it's going to be a project. And you can write those in several different places. Most importantly, in your build source folder, when you want a little plugin just for that project. Or you can put it in a standalone project, publish it to the plugin portal or your internal Maven repository, and then use it from everywhere. So those are the plugins that most of you are used to. It's also what all the Gradle core plugins look like. But there's more. Many of you have probably broken down their build scripts into smaller, more manageable pieces, probably putting them into the Gradle folder in the root project. Like, who does that in his own projects? Yeah, quite a few of you. So those are called script plugins. Many people just refer to them as scripts, and that's okay, but it helps to think of them as plugins, just like the ones above. You just take the class, you remove the class declaration, you remove the method, and you just write the method body. That's your script. Yeah? Internally, what happens is Gradle will put that code into a class with a method, with an apply method, and compile it. And behind the scenes, it will work just like a binary plugin. There's no difference there. So these scripts are also plugins, and you can write them, again, apply them to any target. And now comes what's probably surprising for some people, because we don't advertise this fact a lot, but your project's build script is also a plugin. It's some piece of logic with some dependencies that applies to your project. So your project's build script really is just another plugin. And the same goes for the settings script. It's a plugin that applies to the settings instance. Or init scripts. Those are plugins that apply to the Gradle instance. And if you really internalize that, it's a very powerful fact, because it means that you can take anything that you did in a build script and move it to a script plugin, and it'll work. And you can take a script plugin and write a class declaration and a method declaration around it, and you have a binary plugin. Yeah? So anything that works in any of those can be done in the others. There's no distinction between them. It's really just a slight technical difference. Yeah? So this is very important. And we will even see some other things that should be thought of as plugins in a second. Because what often happens is you have 100 projects, or even more. Like, who has more than 100 projects in his build? Yeah. So when that happens, you don't want to repeat yourself all the time. You don't want to go into every sub-project and say, oh yeah, you applied a Java plugin. You applied a Java plugin. You applied a Java plugin. No. You want to have that at one location. You want to say, OK, all projects that are under this directory, or all projects that end with this name, are Java projects. So this is what we call cross-configuration. You take a piece of logic and apply it to all sub-projects of a root project. Or you have an init script that applies some logic to all projects in a build. Yeah. And when you think about that, if you look at this all projects block or sub-projects block, what's in there could really be thought of as a plugin. Yeah? It's not a pull mechanism, it's a push mechanism, basically. You're defining some piece of logic, kind of ad hoc. It doesn't have a name. Yeah? It's just some piece of code, and you push that down into other targets. So this is what happens, for instance, with root projects. You have some piece of logic, push it down into all your children. The same with init scripts when you have this all projects block. You take some piece of logic and push it down into all those projects. Now, this is currently not the case in the current model, but this is where we should be going, thinking of these things also as plugins. So if I want you to take one thing away today, then it's plugins all the way down. Now, Pepper's going to tell you a little bit about how the old plugin system models this all, and then we'll see what the problems with that are.
Sure. So how does the current system apply plugins? Hopefully, for most of you, you've seen or are familiar with this code, but I'll take a quick walk through it and kind of explain what's going on. So you define a build script block. Within your build script, you're basically defining the dependencies that are needed for your build logic, the repositories where the libraries that actually package the plugins live and which versions of those libraries to use in the dependencies block. Then, in this example, I've got the application of 3 different plugins just below the build script block. So that first one just applies the org example A plugin that is the plugin identifier that is packaged in the org example plugins library, right? The jar file. Now, inside that jar file, there's also some metadata that says, hey, this jar file includes org example A plugin and might include other plugins as well. So down lower, you see the org example B plugin. That's also available on the class path because we said in the build script block, go find this jar file, put it on the class path. The second apply plugin is for a core plugin, Java. So those are always available on the class path of the script. You just have to apply it by ID, and it is materialized. apply from scripts, myscript.gradle is just a relative path to where you have a script plugin defined, and you're, again, going to apply it to the target that is this project. And then there's the subprojects block, which will go to all of the subprojects and apply the plugin, B plugin. Plus, this is also where you would put any cross configuration. So if you want to reach into some subproject and say, now that I've applied that plugin, I also want to set some variable or something in an extension, that's the spot to do it for all of your subprojects. Now, I'm showing you this syntax to point out a couple of things. One is just that it's kind of large, and that there's a bit of ceremony involved in it. Here's how this actually works inside Gradle. So I've kind of simplified things down and shown you the script. But what you might not have thought about right away is that if I'm defining the class path in the build script, then we kind of need to know what those classes are before we can actually deal with doing something with them, right? So the way we process any build script in Gradle is two passes. The first pass, we just go find the build script, and we set up the class loader with everything that was defined in those dependencies. And then we pretend like that's not part of the script anymore, and we, in a second pass, process everything else. So now that we've got a class loader set up, we can actually load the plugin task and the some plugin variable that was defined inside those classes and actually use them to configure the target, whatever the target might be, right? A project settings or the Gradle. So 2 passes for every script. Now, interestingly, that if one of these apply plugins had been like an apply from some other script, then we would have gone to that script, done the first pass to pull out the build script, and created a second class loader just for that script's dependencies, and then run whatever's in the script in the second pass. So it's not like we upfront pull out all of the build scripts and make a bunch of class loaders and then execute them all. It happens for each script in 2 passes. Okay? This gets interesting later, I promise. So another thing that you need to understand about how we currently handle plugin resolution and application is that we have this hierarchy. So here I'm representing like a hierarchy of projects, right? There's a root project with multiple subprojects beneath it. When we go through pulling out the build scripts and creating class loaders, we do that in a exactly mirrored hierarchy of class loaders. So if you're familiar with how Java does class loading, this is really important because you basically always ask your parent class loader first if they have a reference to a class before looking for it in your own class path. So we set up this like parent-child relationship for projects and subprojects, and that makes cross-configuration possible, right? Because basically when the root project has injected or discovered the classes that needs to be in its class loader, then those classes are available for the subprojects, and when you're like inside the subprojects applying them, you're actually talking about the exact same class. In fact, when we go and resolve libraries for some subproject, we do we search for conflicting versions and make sure that we're always using the latest version. So it could be that some subproject might say like apply apply plugin B. So in the parent project, we've applied plugin A, and it depends on like Guava version 12. And then down in some subproject, you apply some other plugin B, and it depends on Guava version 19 or whatever. Well, we'll make sure that like Guava 19 is used by the entire class loader hierarchy. Does that make sense? Because we can't have like multiple versions being resolved. Okay. Good enough. So back to Stefan to talk about how this breaks down. Seems like it should just work, right?
Well, yeah. Would be nice if it just worked. No, there are many problems with this approach. So the first one, obvious one, is verbosity. Who's tired of writing build script blocks? Thank you. So it's just verbose. When you wrote your binary plugin, for instance, you gave it an ID. And now the user of the plugin, apart from just knowing the ID, so you can write apply plugin and then the ID of it, he also needs to know which jar this comes from and from which repository. Why? Why would the user care? Yeah? So we have like 2 different identifiers, basically, that the user needs to know about. Completely unnecessary. The next thing is, if you look at the subprojects or all projects blocks, they are eager. So if you're in your root project and you want to avoid duplication, so you put a lot of logic into your root project and say like all subprojects should have this plugin and that plugin and that plugin, and then the test tasks should have this logging level, and then all Java tasks should have UTF-8 encoding and so on. It makes sense to do it that way because you don't want to repeat yourself. But one thing you might not realize is this is all executed eagerly. So as soon as you execute the root project's build script, you are eagerly walking over all the subprojects in your build and executing all that logic, which is expensive. Now imagine you're just running a task in one of your subprojects. You're running compile Java in one project of a 500 module build. And this project maybe transitively depends on 10 of those 500 projects. You're still gonna configure your root project. And if your root project has one of those blocks where it iterates over all the children, applying a bunch of expensive logic, well, then this whole on-demand, configure on-demand feature that we have is useless. Yeah? So even if you switch on configure on demand and Gradle only configures the projects that you need for this build invocation right now, if you eagerly walk over all the subprojects in your root project, it doesn't help you much. Yeah? It's still gonna eagerly execute all that logic. And the same goes for parallelism. So when you walk over your subprojects and apply a bunch of cross-configuration to them, you're doing so in a serial fashion. Going to project 1, apply all the stuff. Project 2, apply all the stuff. 7 of your cores are just sitting there and being like, what the fuck? I'm bored. So even if we had, like currently Gradle does configuration serially, but it's an obvious improvement to configure projects in parallel. But even if we had that, if most of the action happens in your root project, well, then you have one bottleneck. You have 90% of your configuration logic going on in your root project. Parallelization won't help much. But there are other problems with this approach. For instance, you saw all those apply statements sprinkled over Pepper's code, as he always does. And the problem is, you're an IDE now, and you want to give me autocompletion. You want to tell me, hey, what tasks are there now? What extension objects are there now? Well, I don't know, because the IDE would have to execute your whole build script to know all the plugins that are applied. Because there could be an apply statement at the very end, or somewhere in an if statement, or nested in a subprojects block, et cetera, et cetera. Yeah? And this makes it almost impossible. I mean, it is theoretically, of course, doable, but it's insanely hard to give you good autocompletion with that model. Because think about it. When you're doing autocomplete, what state is your script in? It currently doesn't compile, because you're hitting autocomplete because you're currently typing something that is not complete, right? So if you were to try and say, OK, for autocompletion, I need to compile the whole script, but wait, I'm doing autocompletion, so I can't compile because it's currently broken, how are you going to tell the user what he can do? It's not possible. You need a more easily discoverable set of plugins. Not doable with this approach. Other tools that might have trouble with this are, for instance, the build scans. Build scans can, of course, tell you which plugins were applied because they listen to the whole project evaluation, and then they tell you, OK, these 64 plugins were applied to your project. You probably saw that in Hans' keynote. But what they can't tell you is when, where, by whom. Like, who transitively gave me this weird plugin? I don't know. Could be anywhere, because it's just some piece of imperative logic. Another problem with it is also some plugins are discovered too late. So we've seen these apply from statements. We go in 2 passes. We have the build script block, which sets up our class path. And then we execute the rest. Now, the apply from statements, which apply some other script, they are in the second pass. So we already have set up our class path. We can't change that anymore. And now we say, OK, but I want to have this script plugin applied to me. Now, that script plugin might have some other dependencies, or it might define some API, it might define some task or some extension object. The problem is, your project can't see it, because whatever is in that script plugin was discovered in the second phase of your project's build script evaluation. And your class path is already finalized. You can't add something after the fact. So you might have discovered this. I don't know if anybody has ever tried applying some community plugin in a script or write a task in a script. Yeah, Ben has. And the reason why many of you probably didn't do it is because you've read some horror stories on the forum about it. I don't know. So it's very hard. So you expect it to work, but it doesn't because the class path is discovered too late. Otherwise, you could just take some piece of code, like apply this plugin and configure it, and put it into a script plugin. That should work, currently doesn't. The same goes for init scripts too. Init scripts don't have the problem that they're too late, because obviously they are executed before everything else. So you have the possibility to add stuff to the project's class path, but you have to make a decision, because the init script itself has a class path that is different from the projects that it is configuring. So you have to make a choice. Either you put some library on the init script's class path, then the init script can see it, but the projects can't refer to those classes. Or the other way around, you add it to the project's build script block, then the projects can see those classes, but the init script can't. So you can only work with reflection and other hacks. And also, this should just work, but due to this current class path mechanism, it doesn't. And then, of course, since there is one class loader, one flat class loader for every build script, you end up with problems when you have two plugins that depend, for instance, on different versions of a library. One of your plugins depends on Java version 12, the other one's Java version 19. We do conflict resolution and select 19, and the one that needed some API in Java 12, which is no longer there in 19, just breaks. I guess a lot of you have already experienced that, trying to apply some plugin that hadn't been maintained in a while, and it doesn't work with other newer plugins. So those are all the problems that we currently have that got us into thinking, OK, we need a new mechanism here. And of course, first we sat down and thought, OK, what should this new mechanism do? What should it look like?
Right. And so in a lot of ways, the goals that I'm about to discuss are basically just a reframing of like, well, let's not have that problem anymore, all right? But I just want to kind of like quickly go through them and call them each out. So we want there to be, I went too far. We want there to be a concise declarative DSL. We need to basically not be worried that we're going to be running some sort of imperative logic, or that we're going to be repeating ourselves in this like very verbose way and saying like, oh, you know, this is where my repositories are, this is where my jar is, this is the plugin that's inside that jar, over and over again. We really want to support easier machine readability and editability. It's excellent work, if anyone caught the previous presentation, that Netflix is doing with the Gradle plugin. But as the presenter John said, a lot of it is based on the fact that most of the time there isn't dynamic stuff going on in an apply statement, like apply plugin statement. But if there were dynamic or conditional logic being applied, it would be very difficult to do that sort of automated tool manipulation of your Gradle files. And we want to enable that as more of like a first principles use case, where we support that sort of readability and editability by tools more fully. Our eventual goal would be to have all plugins discovered very early, so that we can basically set up all the class paths, all the class loaders, right at the beginning of the build process, and then do all of the execution separately. It's great for being able to just optimize, and also it's great for caching, so that if we knew everything up front, it would be just easier not to have to deal with like, oh, surprise, that plugin that you applied another plugin, and you didn't know about it until it was too late. Again, this is just kind of a restatement of a problem. It needs to be easy and straightforward to apply plugins from init scripts. as well as from inside script plugins. We really want to support parallel cross-configuration. So the problem that Stefan was talking about, where if you have used in your root project subprojects block or all projects block, and you're applying cross-configuration across hundreds and hundreds of projects, you've basically created a bottleneck in your configuration in the root project. And we want to be able to parallelize that. We also want to be able to do on-demand cross-configuration, which is if my build invocation is just, run the classes task for one of my subprojects, then we shouldn't have to configure all of the subprojects to do that. Configuration time, it turns out, on very large projects can be, in certain use cases, like ridiculously wasteful. So we want to be able to do that on demand. And then finally, and this one I think is one of the coolest things that we're sort of ambitiously looking forward to the future to be able to do, is to isolate the class loaders that we're creating using for plugins so that on the plugin basis, as opposed to on the target basis. So like right now, as you saw, we have like all these class loaders per target that you're configuring, or build script rather, that you're running. And we think that it really would make sense to be able to say like, hey, this plugin has some dependencies that it needs. It can have exactly the versions of the dependencies that it needs, because while it's running its application, it doesn't need to be exposed to what some other plugins classes are. Like if it says these are my dependencies, we can construct a class loader just for running that plugin. So we want to be able to support better class loader application. I kind of contrast this to your applications dependencies. Obviously, your application dependencies, because it's one application that does some number of functions, needs to have like one class path at runtime that it's running with all of your dependencies on it. But plugins are a little bit different, because we're not just creating like one like large thing. It's a bunch of different chunks of code. But encapsulating build logic is what plugins are all about. And we should also be able to encapsulate what they depend on and isolate that from all of the other plugins in a build. So that's kind of what we set out to do. Like let's change the plugin mechanism and make it have these properties. But that's not where we are right now today. So let's talk about where we are and how we got there. So here's what we had for Gradle 2.1. Basically, we made a concise declarative DSL that got rid of some of the verbosity. And it's useful for the core plugins, for community plugins, and plugins published. It also allows for publishing plugins to the plugin portal. Here's an example of what the syntax looks like. You simply say plugins, ID. Java is a core plugin, so you only need to provide the ID, and we know that it's the one that's with this distribution of Gradle. The second line, it says, this is the ID of my plugin. It's at version 1.2. As long as that plugin has been published to the Gradle Plugin Portal, then we have the metadata in the plugin portal to know exactly what jar that maps to, and we can pull it down and put it on your class path. And then the last one, just to point out that this is not a complete solution right now, this is how you still apply a script plugin. So basically, script plugins are still apply from this relative path. That's where we were. State of the world is 2.1. In 2.14, we've added the ability to resolve from custom repositories and to publish to custom repositories. So the Gradle Java plugin, or Java Gradle plugin,
Java Gradle plugin.
The Java Gradle plugin will automatically publish to your custom repositories. I mean, you have to configure it and say where they are, but it now can publish to them. And we can resolve from those custom repositories. So this is what the code looks like in your settings.gradle file, and only in your settings.gradle file. You can put a plugin repositories block and say, this is where my project gets its plugins from this Maven URL. Oh, and also if you don't find it there, go look in the Gradle Plugin Portal. If you leave out the Gradle Plugin Portal here, you'll only find plugins in your custom repository. And actually, that's the use case that we designed specifically for. There are some people that basically want to be insulated from whatever randomness we might actually put up on the Gradle Plugins Portal and only want to use the plugins that they've chosen to mirror in a local repository. So if you do define a plugin repositories block, be sure to remember to add the Gradle Plugins Portal if that's where you want to get it from. Yes, sir? It does not support Flutter. It's at Maven, Ivy, and Gradle Plugin Portal at time of writing. But if that's a very important use case, like, please let us know in the forums. We're looking for a lot of feedback on this mechanisms. So then, as of 3.0 milestone 2, we've also made it possible to resolve a plugin but not apply it immediately for the use cases of reusing logic that plugin provides, like the classes and things that it provides, but without actually applying it to your target. And also to be able to apply it to different targets. So in the first step of cross-configuration is often to apply some plugin to a bunch of subprojects. And here's what the syntax for that looks like. Basically, we just added this apply false possibility. So you can say when you're applying a plugin ID, its ID, its version, and then apply false, which just means that we'll resolve it, we'll put it in the script class path, but then it's up to you to decide when you want to apply it. And for now, the cross-configuration piece of it is still the same syntax as previously supported. You just say, apply the plugin with that ID, and it works. We want, in the future, to also come up with a more sophisticated mechanism for cross-configuration, but this is where we are right now.
Exactly. All right. So now the question is, what can you do today? We believe that the plugin system with the additions we did in 2.14 and 3.0 is now, should be considered the way to apply plugins for most projects, because it supports the most important use cases, and it's much more concise, just much nicer to use. And also, all community plugins really should be in the plugin portal. That's where everybody searches for them. So the first step that you can all do is, if at all possible, migrate your builds from using the build script block to using the plugins block. Benefit from that concise DSL now, and you'll benefit from all the other improvements we will keep adding in the future. And of course, also, please let us know in the forum your experience with that plugin DSL. So we really want to get to the point where we say, OK, take off that incubating flag, because we believe it's ready for prime time. And at some point also, deprecate the build script block. That should be the goal. But that is only possible if everybody tells us, OK, so here's the 3 things that it doesn't do for me that I really need. So we need to know those things. We are, of course, aware of some of them, but we want to know which are the most pressing. What should we prioritize? What's most important to you? So let us know in the forum. And since we have some time left, and probably many of you have already given it a try, we thought we'd just open this up for questions. And
I actually did want to go back and talk about one thing that I forgot to mention. In both the plugins block and the plugin repositories block, we've started out with a very strict syntax, and it's very limited. So, for example, we won't do any variable substitution at all in those blocks. We only are using string literals. We know that some things we aren't going to be able to be that strict on, but with dynamicism, with the ability to use variables, with the ability to insert conditionals and that sort of thing, comes sort of compromises on just how upfront we can load everything and run everything, right? So we're trying to make sure that we do those trade-offs in very calculated and incremental ways. It's a lot easier to loosen those restrictions than to tighten them down after we've loosened them, right? So in these blocks, we're starting out very conservative, very little dynamicism, but we're listening. We're interested in use cases where we are like, OK, we definitely need to support Gradle.properties. And I would say that that's one of the things that we're learning right now in the forums, for those of you who have been following along, is that we expect Gradle.properties to be interpolated directly into those strings, and here's why, and here's our use case, and it totally makes sense. We just started out super conservative and are loosening instead of trying to start loose and then take things away. OK?
All right.
Questions?
So the community portal, is that just a Maven portal, or is that, in the past, all my builds have had to be behind firewalls with the proxies?
OK, so the question was, is the plugin portal just a Maven repository? Yes and no. So the plugin portal has metadata that allows us to do this very short syntax. Behind the plugin portal is also a Maven repository, but right now you cannot mirror it so that you can use the new plugins DSL. So this might be one of the use cases where we say, okay.
So behind a firewall, it's useless then. Can't use it at all.
So this might be one use case. Adding
the file example that came up is another case when reporting scripts into the DMZ that has no internet access. Typically, the process is to have a task to build yourself a flat file and then port the archive into the DMZ with an alternate channel.
Yeah, but it's also very simple to publish to a local Maven repository, and that Maven Metadata allows us to a much simpler mapping from plugin ID to the actual plugin implementation, because you can have several plugins per jar, so you need a mapping from the ID to the actual plugin, and we do that by just publishing little POMs or IVXMLs that have the ID as their artifact ID, and then a dependency on the actual artifact that implements that plugin. Now with flat tiers, that gets a little complicated, and you can just use the publishing plugin to publish to a local Maven repository or Ivy repository. So that's why we didn't prioritize a flat tier mechanism very high.
So use cases behind firewalls, use cases in no network situations are highly notable.
Yes.
Yep.
So this is one of the things we might do, like make the plugin portal mirrorable, basically adding those markers that I just talked about and allowing you to just mirror it like a plain old Maven repository behind your firewall. Yeah. Okay.
So I have a comment on that, because that's the sort of thing that we do on a regular basis. Typically what we've had to do is look at an individual plugin, make sure we're in compliance with the license, make sure we are able to download it specific, and then we have our own artifactory that sets it all up within the closed network. So it is possible, it's a little more process-oriented, but it can be done.
Yeah, of course, you can also have a manual selection mechanism where you say, we take those 5 plugins from the portal that have been verified by our legal staff, and we publish them to our own Maven repository and add those markers.
Or your security staff.
Or security, exactly. Yeah. And you can just use the plugin publishing mechanism that we've added to the Java Gradle plugin and publish to your own private repository. Yeah.
Is there like a business reason why not just go ahead and open source the plugin portal itself and the plugin that publishes to the plugin portal, even if there's not an immediate way that you could set that up internally?
That's a good question. I don't have an answer to that, honestly.
The reason I ask, we've got, I think we reported 3 or 4 like individual bugs with the plugin portal and the mechanism that publishes it today. Like we would just fix that stuff.
Yeah. So
And you're not making money off of it. So it's good.
that is a valid point. So I think there was at some point the idea to like turn the plugin portal into a product, into a cloud service, basically. But we might like reevaluate that question because build scans has a much higher value proposition currently. It might actually turn out to be 2 things. So the basic infrastructure to like publish plugins, that's nothing that we'd say like, oh yeah, that's going to be a great business opportunity. It shouldn't be. That's a foundational piece of Gradle. So it might be an idea to open source that and then maybe have another service that builds on top of that and gives you all kinds of analytics about, oh, hey, where are your plugins used? Who's using old versions of those plugins, et cetera, and make that a service. So that's a very valid point, and we will think about that when we design the next additions to the plugin portal, because that also needs some love.
Yeah. You had a question?
So you just mentioned that plugin ID string that we give, it's very strict right now. We won't have any variable substitutions in those things. So can we have something like for version, can we give like a range or something? Or we have to give like hard-coded versions?
Yeah, so this is like the very next thing that we want to support is like the dynamic versions. We've been doing a lot of like deep thinking. Obviously there's a lot of trade-offs when you use dynamic versions. I mean, Netflix has done a lot of work to like be able to lock and have reproducible builds for dynamic versions. But we're just trying to figure out exactly how we want to spell it and if we want to support the same kind of syntax. Right now, it doesn't work. But it's like really the next thing that we're teeing up to figure out.
So I would say dynamic versions aren't great because they can break your build at any point. If a new version of a plugin comes out and it somehow breaks, then suddenly your whole build doesn't work anymore, which is I would say a little worse even than when some application dependency is updated and it breaks your tests. At least your build still runs and you can analyze some stuff, but if the build itself is broken, it's pretty harsh. But there are valid use cases in organizations where the developers are really not concerned at all with the build. They never touch it, not even for dependencies, and the build team just wants to say, please, everybody use the latest version of everything that we publish. So for those organizations, having dynamic versions completely makes sense, and it's one of the things we want to tackle next.
You mentioned that the plugin repositories is configured in the settings document. Currently, we configure repositories in Init document. And I had to brush up on exactly how the settings.gradle stuff works. It seems like you would have to configure that in each project. Is there a way to configure that more globally? What is your answer there?
Yeah, so the question was, is there a possibility to specify the plugin repositories in Init scripts? That is on our roadmap too. So obvious use case, you want to lock it down for all the builds in your organization. Yes. So we started with settings.gradle because that was like the simplest first step towards this, and Init scripts are an obvious improvement. Yes.
Is there no other way to get around that than even with a custom distribution, custom Gradle distribution?
Currently, there is no way to get around that, but it is pretty high on the list, like for the second iteration of this plugin DSL work to allow that in Init scripts. Yeah.
Any sort of idea on when that might land?
I can't give you like an estimate right now because like after the summit we will have like a prioritization like meeting.
Yeah, we can give you an estimate about when we might know about when it might be, which is like a week or two from now, right?
Yeah, exactly. So like after our own internal meeting, we will have a better idea which projects we want to start in the next 6 months.
Yeah.
Right now, I don't have a good way to have a custom plugin bring online a community plugin. If I write up a plugin that basically I'm extending the Java conventions with my own set of conventions, I can say my custom plugin, apply plugin Java to every project I apply conventions to. That works. I can't pull in a community plugin because I can't affect a project's build script class path when I'm already in a plugin.
Oh, okay.
So is there a good mechanism for me to be able to apply community plugins to projects through my custom plugin? Just
So,
have one custom plugin
yeah.
to do that.
The question was, can I apply other community plugins in my own plugin? And I think you're talking about a binary plugin. So yeah, okay. So you just depend on them. So you have like in the build script of your plugin, you say repositories plugins.gradle.org/m2 dependencies, whatever the jar is that community plugin is in, and then in your plugin you say apply plugin that community plugin.
Okay.
So it's just another dependency. Just like you would depend on Google Java or whatever your plugin needs, you depend on that other community plugin in a certain version, and then you apply it. Yeah. So this is also still using that old mechanism, or current mechanism. At some point, we of course also want to make that more declarative, because what we really want is when your project says, I want this plugin in the plugins block, then we also want to analyze that plugin and see, okay, what other plugins does this apply, so we know this up front. So it might be that your plugin has some kind of metadata later on where it says, okay, I also apply these 3 community plugins. But right now, you just use the normal dependency plus apply statement mechanism.
So that would be with the current model.
Yeah.
Yeah.
That, what you're talking about, would not be supported under the new model yet.
Well,
Correct.
it works. It works perfectly fine. It's just some of the future improvements that we want to do, like discovering all plugins that are applied up front without executing the actual build logic. Yeah, like that would not be supported with the current apply statements. But it works perfectly fine. It just doesn't enable some of the things we want to do in the future. So this will be an addition, like we will improve the Java Gradle plugin further to allow you to say, okay, I also apply these plugins declaratively instead of imperatively. And then that will enable Gradle to do more analysis upfront. But it works perfectly fine with the plugins block. You just depend on that other plugin and apply it in your apply method.
Thank you.
You're welcome.
I'm sure I'm not the only
for this,
You're welcome.
doing the private repos.
Oh, great. Good.
You're very welcome. Okay, so our time's over, but we'll be around for your questions. Thank you very much.